Hello there guys, welcome back to another epic Inexorable maths video. In this video we're looking at some integration. We're looking at how we can go about integrating sin² and cos² with respect to x. They're a bit difficult to integrate directly. Let me write them in. Because they don't have a standard integral. And there's no rule that's going to help you too much. Or at least there's no easy way to do it. So what we really want to do is integrate sin² and cos², but let's do sin² first. So how can we integrate sin²? Well, the way that we are going to do this is actually by considering a trigonometric identity which comes from the double angle formula, which I will leave the link to in this video's description if you want to check that out. But there's a double angle formula equation. We actually use the same one for sin² and cos², luckily. And it says that cos of 2x is identical to, well, two things, but, well, I'll write down all of them. The first one is, well, three things really. The first one is cos² minus sin². The second one is 2 cos² minus 1. And the third one, and the one that we're going to use here, is going to be 1 minus 2 sin². You can see that as long as you can get to the first one, you can also get to the second two by replacing cos² with 1 minus sin², or sin² with 1 minus cos². You can rearrange to get the others. But I've got a video, which the link is in the description of this one for, if you want to check out and see why this is true. But we're going to basically exploit this equation, or one of these equations, to integrate sin² and cos². So the one that we're going to use for sin² is the bottom one. Cos 2x is identical to 1 minus 2 sin² x. Okay, so let me write that again. Cos 2x is identical to 1 minus 2 sin² x, which means that cos 2x minus 1 is identical to minus 2 sin² x, which means that sin² x, if we just divide both sides by minus 2, sin² x on its own is identical to a half minus a half cos 2x. That is sin² x. So if we want to integrate sin² x, we can just actually integrate what it's equivalent to, which is much easier to integrate, which is a half minus a half cos 2x. So let's just integrate this, because this will give us the same result. And this is easier to integrate. So how do we integrate this? Well, the first part is a half. Well, a half integrates to just a half times x. Minus a half cos 2x is actually going to integrate to minus a quarter sin 2x. And we can see this because if we differentiate sin 2x, the 2 will come out the front, multiply by the minus a quarter. 2 times minus a quarter is minus a half. Sine becomes cos. There's still a minus sign because positive sign differentiates to positive cos and negative sign differentiates to negative cos. So negative sign here is still going to differentiate to negative cos. That's absolutely fine. Lovely. That's our answer, plus c. So this is the integral of sin² x. The way that we integrate cos² x is basically the exact same. We can recall that cos 2x, as well as being equal to 1 minus 2 sin² x, it's also equal to 2 cos² x minus 1. This is the other double angle formula. So if we rearrange this to get cos² on its own, this tells us that cos² x on its own, if we add 1 to both sides and then divide by 2, we end up with a half cos 2x plus a half, or a half plus a half cos 2x, if you want to write it like that. Which basically means, let me move the camera there, the screen, it basically means that the integral cos² x dx is just going to be equal to the integral half cos 2x plus a half with respect to x. So again, this is an easier integral, and this is going to integrate to the following. A half cos 2x is just going to integrate to a quarter sin 2x for the same reasons as before, because if you differentiate sin 2x, you get 2 times cos²x. The 2 cancels with the quarter, making a half. And then a half just integrates to a half x. And then we add our plus c on the end. So cos² integrates to a quarter sin²x plus a half x plus c. And sin²x integrates to a half x minus a quarter sin²x plus c. It's very interesting. They look very, very similar to each other. There's just positive and negative signs. But that's how you integrate sin² and cos². And this also works the same way if you want to integrate sin² of 2x or something like that. You can still use the double angle formula. You just end up with a 4x out the front in the answer. So you can still use the double angle formula. Let me know if you want to see that video though in the future. This is how you integrate cos² and sin² in one way. I think there's other ways to do it, I'm pretty sure. But that's one way to do it. That's the easiest way to do it by far. Hope you enjoyed this video. Thank you guys so much for watching, and I'll see you in the next one. Cheers.